pictures
on
beforehand. But don't worry about that, it's the context that counts.
Right, one quick question.
Before we get to
Was
pictures...
anybody before it got here got given the keys by the choir before they buggered off, no?
They didn't give me any.
Right, there's another group and they don't have
There's
keys
another
either.
meeting, I think, in the
They don't have
room.
keys either.
Oh, wow, I don't
So the guy in the choir is away with the keys.
Oh, well.
Can you
Okay.
further go to demand that?
We'll just wait to have them maybe
Are
come
we
back or
ready for
something.
me to start
Yes.
then? Well, when I want to change pictures, I will say next, okay?
Okay.
Right, before we get to pictures, let's take a little look at history. Back in 1956, when I was studying psychology at Geneva, a 29-year-old physicist was invited to join a design team in the States for a new accelerator for protons. And he came up with the idea of storage rings. He stuck with it and others dropped out, so by 1965, when the first high-energy colliding beam experiment was carried out by his group and proved that the electron's size was 1,000 times smaller than a proton, in scientific and political circles he became reasonably famous. This nuclear physicist's name was Gerard K. O'Neill. Most of you have already heard of him in another connection. Next. However, first, let's talk briefly of another guy. This is a pic of Dr. Peter Glaser, who died a couple of years ago, aged 90. Back in 1968, just 3 years after O'Neill's group's calculation of how small electrons are, he published an article proposing solar power stations could beam down power from space to Earth. Next. Later, the US National Space Society came up with this diagram of how they might work. I'd like you have a moment to have a wee look at that. Next. Perhaps looking something like this. Next. NASA later developed this idea. The concept was developed and planned throughout the 1970s and early 1980s. Next. However, 1 year after Dr. Glaser's first article on solar power stations, a couple of months after Apollo 11, in October 1969, Gerard O'Neill asked a seminar of students this question: is the planetary surface the right place for an expanding technological civilization? Next. That was 1969. Since then, we've got this, today's International Space Station. So far in our space settlement talks, the Moon and Mars both looked okay, but Venus and Mercury both needed more info. So let's consider another way, settlement in space itself. Next. Space hotels. This is one of my own design of 16 rockets, nose to nose, and 4 crosses attached, 2 crosses at each end of zero-G area, containing theatre, tech labs and gymnasium, with cross pairs spiralling in opposite direction, giving 1G in the crosses, where folk would have their bedrooms and there'd be a restaurant, etc. Docking would always be in the zero-G area, and folk would travel along cables in cars to the crosses. Next.
Where's the zero-G area?
The zero-G area is where that rocket is. That's the zero-G area, and there's a cross there, and a cross there, and a cross there, and a cross there. And they're both going in opposite directions.
So they're rotating that way?
One lot is rotating that way, and the other lot is rotating the other way, and that keeps the whole thing stable.
Right, so the gravity is always pointing to the end of the cross?
Yes, the thing, the zero-G area stabilizes.
So you have floors inside that,
That's
presumably,
right,
then?
yeah.
Okay.
Yeah.
What does it have to rotate it to get 1G?
Well, if the thing is long enough to cover, shall we say, around 4.5 miles, you can rotate the thing, and it'll be 1G in each of the crosses.
Yeah, how fast does it have to go for
I'm
that?
not quite sure of that offhand. This is Lockheed's design for what they call a moon gateway.
This is the thing that's going ahead now.
If this gets built, it could be a good base from which to build Island 1. Next. Probably at L1. But note, while it takes 2.5 days by rocket to the moon's surface, it'd still take 2.5 days to L1, from which it would then take 2 weeks by a lunar elevator at present speediest elevator velocity down to the moon's surface. Most folk would go by rocket all the way, but the curious and those wanting safety with most cargo would take the L1 route. Next. Apart from the moon, we'll need bigger habitats, and that means we'll need space elevators of some kind from Earth. Perhaps the 20-kilometre high inflatable tower like this, or, next, the full space elevator, as soon as you have powerful enough cable, which will need up and down ground capsules such as these. Next. You'd need somewhere to get on and off at LEO, low Earth orbit. Next. But the main elevator would be more like this. I'll leave you for that for a minute to grasp the point that very top part is a long way above geosynchronous orbit. Most people tend to think of the space elevator as high from geosync, but it goes a lot further than that, because otherwise it's not going to be balanced.
And there's a counterweight.
Yes, that's
That was
right.
Clark's idea, wasn't it?
It was indeed. Yes.
Is that to scale?
No, that is more or less to scale, yes. The next one, next. Here's one that's not to scale. Well, this is the one that's not to scale, but it shows clearer what everything is. HEO stands for High Earth Orbit. So in the previous one, that would be the one that's way high up. This is because you have to have the balance a lot lower down.
You're going to need a big mass.
Next, around geosynchronous orbit, it might look like this. Next. Believe it or not, this vernal sphere was designed 5 years before I was born, and I was born back in 1934, 82 years ago. Vernal sphere.
Vernal.
Who did that? Was that Albert?
5 years before I was born in 1934, 82 years ago. So this was thought up in 1929. John Desmond Bernal, who designed it, was a 28-year-old pioneer of crystallography in molecular biology, who was born in Tipperary, and obviously had fairly wide thinking. Next, here's a schematic of his design, and the front part is just the same as the back part, only it's not quite got all the bits so as to make it clearer to see. Next, here's an idea of what it might look like inside, with between 20 and 30,000 inhabitants. This would be what US physicist Gerard O'Neill calls Island 1. Next, here's another look from lower down nearer the Central River. Next, the plan was that the material to build the Island 1s would be sent up from the moon by a mass driver using magnetic energy to fire the material up to the required space location. And mass driver experiments showed that this could be done. That long line there is the actual mass driver. Next.
It's just an accelerator, your mass driver.
Yes. The problem with this would be space law. You might like to read that. Article 2 of, well, comes. Let's go to the one immediately below. Article 5 of the Moon Treaty says those involved have to make public reports every 30 days. There, you'll notice at the bottom it mentions Article 5 there. The Article 2 of the Outer Space Treaty says outer space, including the moon and other celestial bodies, is not subject to national appropriation by claim of sovereignty. It means by means of use or occupation or by any other means. That was passed in 1967. The Article 11 of the Moon Treaty says neither the surface nor the subsurface of the moon nor any part thereof or natural resources in place shall become property of any state, international, intergovernmental or non-governmental organisation, national organisation or non-governmental entity, or of any natural person. The placement of personnel, space vehicles, equipment, facilities, stations and installations on or below the surface of the moon, including structures connected with its surface or subsurface, shall not create a right of ownership over the surface or the subsurface of the moon or any areas thereof. The foregoing provisions are without prejudice to the international regime referred to in paragraph 5 of this article. Paragraph 5, as I said, was just really asking them to make public reports every 30 days. We in Space Settlers
What's the international regime referred to in paragraph 5?
That was the Moon Treaty proposed that an international regime should be set up.
To administer.
I'll come back to that. We in Space Settlers managed to stop the UK from signing the Moon Treaty, even though the British Nuclear Society was advising Maggie Thatcher to do so. And American, Russian and China didn't sign that one either.
Good.
In Russia's case, Argentina was demanding its share of Russia's space profits, and the Russians decided, we're not having this, so they didn't sign it. But France and Canada, who is a member of ESA, did sign it, and ESA's HQ is in Paris. So these and all other countries that did sign it can't build Island 1. Unfortunately, almost every country on Earth, including the UK, signed the earlier Outer Space Treaty. So if we ever want to see any Island 1 type habitats built, one of the things we're going to have to do is to persuade the UN to write a new treaty replacing all previous space property treaties with something a great deal more sensible, because there's a lot more articles than those I've shown there. Those are just examples. But basically, these treaties make it impossible to do anything with anything on the moon. And if you do go and live in the moon and build a house there, anybody who wants can walk in and push you out your house and say, I'm living here.
No,
and then the next person can come along and do the same to him.
No, they can't. You can own a house in England.
You cannot own a house on the moon.
In England, you can own a house without owning the freehold of the land beneath it. What that says is you cannot own the land. You cannot
Well,
own the
if
surface
you're
of the
building
moon.
a house,
If you build a house, you own the house.
you don't own the house unless you take all the bricks from Earth. Because if you build it with moon stuff, you're taking property from the moon, which you're not allowed to do.
Well, you're not taking it.
You're
They're building something on the moon.
the
You're
way
not
the
taking
thing-
anything
the
away
way
from
the
the
thing-
moon. It doesn't say that you can't utilise things. It doesn't say you can't exploit resources.
No, but you
it
must
just says
allow-
you cannot own them. So you cannot claim the mineral rights. You cannot sell them to someone else. It doesn't say you
You
cannot
have to
exploit the
share,
mineral rights.
they do say that you have to share everything with anybody else who's there, no matter what their nationality or whatever.
With anyone else who's on the moon.
Yes, anybody who's on the moon can walk into your house and start living there, and you can't stop them. And nobody's going to do this. I mean, it's going to kill.
It's not, you know, I mean, this is quite clearly a load of nonsense and it's out of date. It's absolutely out of date. Now, President Trump...
1967
President
and
Putin,
1979,
Yeah,
it is
yeah.
well out of date, yes, that's
President Trump or President Putin or the President of
Well,
China, I forget his name, they wouldn't tolerate
The
this.
Americans have already made lots of other space laws which conflict completely
Yes.
with the
Uh-huh,
UN
yes.
space laws. But of course, the problem with that is, as soon as anybody actually goes to the moon and tries to do anything with lunar soil or anything, then it's going to be held up by court cases, and that will last for years. The lawyers are expert at that.
China's going to be going later on this year and bringing back moon rocks, and they'll just ignore this.
The Chinese will definitely, yes.
Just ignore it, Andy.
Anyway, next. Jerry Stone and the British Interplanetary Society think a small cylinder would be better than a ball for Island 1. This certainly looks nicer. They are probably correct, a cylinder probably is better. Around a dozen Island 1s, whether balls or cylinders, could be built using lunar material. O'Neill and others calculated that if you had 10,000 folk up there building these and selling the power to Earth, you'd be making more profit on the sale of the power than it costs to build the habitats near the moon. So space population would grow. Lots of folk would want to go as space tourists, and many would decide to stay as it would seem comfortable with controlled weather and free electricity for life. The problem was that after a dozen or so, we'd run out of availability of some chemicals needed for the larger space settlements. So for these, we need to exploit asteroid material. Next.
We've got one quibble with that picture. I'll come back to it.
Well, no.
Oh, come on, what is it?
The water's flat. Wouldn't be, it would be curved. If it's
Sure it's flat?
given gravity,
Yeah,
by
it
rotating.
would be curved, yeah.
Well,
A lot more than it appears to be there, if at all. That's been drawn as flat, I reckon.
well.
Okay.
Argue that with the asteroid, with the artist.
It's curved on Earth, of course.
One small country has already been doing some research in this respect. This is a pic of Tartu University with staff from the Tartu Observatory and some of the students who go there in the foreground, not just from Estonia, but from many countries, to study possibilities for future space settlement. Next. This map at the top shows where Estonia is in relation to Scotland. Its population is about a quarter of ours in Scotland. Below you've got a pic of S-Cube-2, which they plan to put in orbit at around twice the height of the International Space Station. S-Cube-1, which was an actual CubeSat, was orbited as Estonia's first satellite in 2013.
Was that built in Glasgow by any chance?
I actually have a feeling it was built by Clyde Space, but
Yeah, that's what I was thinking.
I'm not positive on that one, but it could well have been. Anyway, next. This is what, this is a wee bit blurred, I'm sorry about that. This is what they, with the help from Finland, the European Space Agency, and a couple of universities, Tallinn University, which is the capital of Estonia, is also helping, plan to do with S-Cube-3. The satellite would be similar to S-Cube-2, but in orbit around our moon as Earth's magnetic field blocks the solar wind, which it plans to use for propulsion. Indeed, the test of that is one of the main purposes of the S-Cube-3 mission. But it would also carry 50 nanosatellites using wind propulsion to investigate up to 300 asteroids, checking their albedo, shape, mass, surface morphology, character, minerals, number and type of craters, fault lines and or moons. Later, robots might be used to mine and bring back the relevant materials needed by the Island 1 construction engineers. Next. In 1976, the Stanford Torus was proposed by Stanford University in the States, and this would be the next stage in satellite building for the inhabitants of Island 1. O'Neill called this Island 2. Next. If you looked in from outside a window, you might see something like this. Next. Stanford produced an explanation diagram that may be a bit difficult to read. Next. Here's a larger version of that first blurb if you want to skip through it, but frankly I would suggest we just skip that unless you want. I can give you
I'm going to make a copy of this, Andy, but unfortunately I've got a stick on me.
I can email you copies.
Right. Oh, I might have a stick in my bag, I don't know.
Next. Here's a rearranged larger version of all the various parts of the thing. Next. Inside it may look like this, but the Stanford Torus could house around 140,000 folk. A lot more than the 30 or 40,000 of Island 1. Next. However, even before that idea was proposed, Gerard O'Neill's students had come up with what is generally called the O'Neill habitat, as he wrote his students' work into an article in the September 1974 edition of Physics Today. He published a book on it, The High Frontier, in 1976. He showed that asteroid material could be used to make internal surface areas of several of these, totaling 3,000 times Earth's land surface, even though at present population growth rates for humanity to continue to, our present population rates for humanity to continue to live within our solar system for 12,000 years. This is a 1977 copy of that book, and it's all in there. Next. Here's an idea of a possible view inside.